Hello guys, welcome to Next Coders. My name is Chanakya, and this is the fourth session in our full Python course in our YouTube channel Next Coders. And in today's video, I'm going to discuss about identifiers, which are also known as variables, and literals in Python. In the last three videos, I had explained about features and applications of Python in real-time world, and also difference between Python interpreter and compiler, and also PVM and Python execution flow. And in the third session, I had explained about getting started with Python, in which we had learned about basic arithmetic operators and print function, and also using IDLE. So in today's video, I'm going to explain about identifiers and literals. So what are variables? I think you had learned this in your seventh class, eighth class thing. Uh, Actually, a variable is location where memories like data values are stored in it, and these values can be updated or used for anything. Actually, there exist two types of memory: stack memory and heap memory. I'm going to discuss about these two types of memory in the next session. But for example, variables can be alphabets or even alphabets with underscores, or even alphabets plus numbers plus underscores or anything. But actually, um, variables are used in Python to reduce the confusion between the values. So we can reuse these variables. For example, the simple example is age is a variable and 25 is a data. And for example, take a variable x. I think you are very comfortable with variable x rather than any variable with words or etc. So assume x equals to 2. So this x is a variable. This is equals to symbol. I think you all know this. And this 2 is the literal. This variables are also known as identifiers. So this is the literal and this is the variable or even the identifier. So these identifiers acts as identifiers. These variables acts as identifier that reference stored data, and these are readable and even maintainable and also reusable in the data. And the literals can be integers or even string, decimals, floats, or even Boolean values. So I will discuss about in the next slide. So I had said why we use identifiers in Python language instead of the values. So identifiers makes code readable. For example, take a number 2523. What does it refers? For example, when we allot a variable which refers student count, student underscore count. When we associates this variable with a given number, we can identify that this number is the student count in a college or even a university. So it enables us to identify what the input value indicates easily automatically by reading the variable, and also for memory management, for reusability and data manipulation, and also program flow control. And even there are some rules for Python identifiers. Python identifiers need to be valid characters, like as I said earlier in the first slide. All variables can be alphabets and alphabets with underscores, or even alphabets plus number plus underscores. But Python should contain valid characters to call it as variables. Python identifier can contain alphanumerical values like alphabets from A to Z. It may be capital or even small, and also it can contains numbers from 0 to 9, or even 1 to 100, 1 to 1000, or even 1 to infinity. And also it can contains underscores, as I said here. But we shouldn't use hyphens, spaces, and special symbols like at the rate, dollar, or etc. And I will open my IDLE and show you the variable my underscore variable underscore 123 equals to 456. Actually, it is taken by the Python, so it doesn't give any error. For example, my dollar variable 123 equals to 896. So you had seen that it had produced an error, that invalid syntax, due to the given symbol dollar. So in Python, identifiers should follow some rules to call them as identifiers, because using of special characters can lead to invalid syntax or even errors. So it costs kind gives confusion to the programmers. And must start correctly. You shouldn't start an variable with any special character or even numbers. As I said earlier, Numbers can be part of the variable, but we cannot start a variable with a number. I will show you the example. Variable 1 equals to 89, so 98. So it doesn't produce it an error, but when we when we reverse it, variable equals to 99, it had produced an error that invalid decimal literal. So we had to understand that variables cannot be started with an integer. So the next rule is avoid reserved keys. There are some keys in Python like class, return, print, etc. So when we write true, it had produced a different color instead of black. When we write the word class, it had produced a different color. So these type of keywords cannot be used as a literal. So I will show here class equals to 9. So it had produced an error that keywords cannot be used as a literal. And it is also case sensitive. It refers that when we use age equals to 90, it shows it had taken the same things. Age equals to 98. It also took it. Age equals to 91. It also take it. Age equals to 92. It also take it. Age 94. So many of them think that it will produce error on giving same age, but in Python it is actually different. So when you print age, it will give 90, and when you print age in capital letters, it will print 98. So case sensitive refers that it shows difference between the capital letter and also the small letter. A equals to 09. Sorry, 3. Uh, I'll ask you a simple question based on the topic that I discussed. Are the capital A and the small a are the same? Does Python show difference on it? No. Python shows difference both of them. They are not the similar. The answer is no for the question that they are similar. So in Python, the small letters and the capital letters are distinct. They are not the similar thing. So when you print a small a, it will produce 89, and when you print capital A, it will produce 3 because Python shows difference between the small letters and the capital letters. So we call Python as a case sensitive language, and it also readability. Readability is next word of Python, next rule for being a identifier. While there is no technical length limit, but identifier should be short so it can be readable by the programmers easily. And I want to tell you a thing: we shouldn't use hashtags for a variable because you can see it produces a different color because it is doesn't run by the Python programming Python interpreter while running it, because the words represented by the hashtags are used as comments. For example, come, it doesn't run it, or when we try to use it as a identifier, it doesn't give you anything. So you can see many of them think that hashtag come is a variable, but it's not, because when you try to print it, it doesn't produce any 65 here. So you can see here many of them think that hashtag any word can use it as a variable, but it's not, because hashtag any word after a hashtag is used as a comment. And now let's jump into the literals. Literals are the values given to the variables. Actually, as I said here, x is a variable and 2 is a literal. It can even be a digital word, or sorry, it can even be a digit, or a variable. Sorry, variable means alphabet, or even a special character or anything. Based on the types, we had categorized literals into 5 types. These are numeric literals, string literals, Boolean literals, special note that non-literal, and it's actually a special literal in Python, and collection literal. Actually, numeric literals are the numbers, are the integers without decimal numbers like 0, 1, 2, 3, 4, 5, 6, or anything. These are actually the numeral literals. For example, x equals to 2. This 2 is a numeric literal. X equals to 3. This 3 is a numeric literal. And x equals to 5. This 5 is a numeric literal. And the second type of literal is the string literal. String literals are actually the alphabets. When we use alphabets to give to an variable, we should keep double colons or single quotes. And we should use, for example, you need to write next. You should keep the next word next between two double quotes or even single quotes. For example, x equals to next gen. Actually, it produces an error because here we had given a comment to print it, but it starts looping. So we need to close here. So to close this, I had written the code next gen. It takes it, and y equals to Chanakya. In the both cases, x equals to next gen and y equals to Chanakya, I had used x equals to next gen I had used double quotes for the next and single quotes for Chanakya. Actually, both are correct without any loss of generality. So when we use the variable z and try to write Python, it actually produces an error because Python is undefined here. So as it is a string literal, we need to use single quotes or double quotes to represent it. Python. Now it doesn't produces. Sorry, we need to close the quotes. So you had seen that it doesn't produce any error for string literal. We need to use double quotes to represent it. And the Boolean literals, actually the Boolean values can be true or false. Actually, true or false. Many of them think that they are string literals, but they are not. Actually, Boolean literals are true or false. True is represented by 1, and false is represented by 0 in binary numbers. And the fourth type of literal is the non-literal. None actually represents nothing. So you can use that. Actually, these are used for fun because we doesn't use it in any programming for any in real-time applications. When you print R, it produces none. So we doesn't need to provide any double quotes or single quotes for non-literals. Also for Boolean literals. And the fifth type of literal is the collection literals. Actually, these are used in lists, tuples, sets, dictionaries, arrays, etc. So we will discuss about these literals in upcoming videos. So uh, this is for this video. So the next session I'm going to discuss about data types in Python. Actually, there exist 6 data types. So in the next lecture I'm going to discuss about the data types and also the type of data types. I hope that you had understood this session very well. In the next video I will present you the best, and I promise you that I will teach you the best in the next video. So if you like this video, please subscribe to Next Gen Coders, and I will also provide you the notes of this lecture. So stay tuned and subscribe to Next Gen Coders.